numericals, I have to explain magnification, linear magnification. This topic was left. Yes, sir, tell me the sign conventions quickly. When you will sign conventions, like suppose, first of all, let me write the topic. Sign conventions. Suppose an object is here. The distance u will be what? Positive or negative? Distance negative. Okay, don't means mix up this u and v with the initial velocity and final velocity, because the initial velocity and final velocity symbol is also u and v. So u will be here negative. And suppose its image is formed here. Can you tell me where object is placed after looking to the center of curvature? So v will be what? Negative or positive? Negative. Fine. What will be the height of sign of height of object? Height of object? Positive. And height of image? Negative. Okay, fine. So that means you understood these signs. In question, they will not give you this sign. You have to put by yourself. Okay, according to the numerical, you will put by yourself these signs. So these are the, you can say, sign. Okay, now tell me the image when you will keep an object between pole and focus. In concave mirror. Between pole and focus, where image will form? Behind the mirror. So yes, so let's start now next we have magnification. So I told you what is the mirror formula? Mirror formula? 1 upon f is equals to 1 upon v plus 1 upon u. This is your mirror formula. Now we have means one more thing we have according to the size. Means sometimes you observe that in your this nature of the image, it is written in diminished, enlarged, magnified, like this is. So that is actually coming from the magnification. What is magnification? Magnification is telling you the enlargement. Okay, magnification means what? Enlarged. So it is means it is the formula of finding out the magnification is that height of the object. Height of the height of the image upon height of the object. You can write like this. In your book it is written I upon O. In others refresher books it is written H2 upon H1. So it depends on you. Okay, which symbol you want to use. All you can means question can be given in all symbols. So don't confuse with the symbols. H2 means height of the object. H1 means height of the image. Similarly, I means it's here height of image. O means height of object. Height. Okay, this is height. I am always using this. You can use this also, that height of image upon height of object. Fine. So if we will look to the this is your magnification, and we can find out the magnification in terms of v upon u also, in terms of velocity, in terms of that image distance and object distance. Means if you know the object distance and image distance, so can you tell me that the image is diminished, enlarged? Yes, we can. Okay, because magnification is also defined as minus v upon u. Minus sign is there. Okay. Minus v upon u. V, if you are talking about the concave mirror, then v will be negative and u will also be negative. So here I have not put the signs of v and u. Actually, every time you are supposed to put the sign by yourself. Your first, you can say first entry will be what? That you will put yourself minus and positive. Okay. This is your negative in the formula only. This is a plus in the formula. So this one more formula, you have three formula. Can you correlate this formula and this formula? Yes, you can correlate. What it's supposed to be? What shape it will take? That H2 upon H1 is equals to what? Minus V upon U. Yes? because if their left hand side are equal, then their right hand side are also equal. So these are the two formulas which we use for finding out the unknown, you can say image, distance, object distance, height of the image, height of the object. Sometimes they will give you height of the object and they will give you magnification, they want height of image. So only one, you know that in linear equation we can find out one unknown thing if two known things are given. So let's start, let's do some question. Theory questions are very, yes, come in. I'm writing here question, okay? Yes, Gibran, have you understood this concave mirror image formation, sign convention? When object, you will keep an object between C and F, where image will form. When you will place an object between C and F, so where image will form? No. Beyond C. See, these two things you can easily remember. Beyond C, image will form, if you are keeping object beyond C, image will form between C and F. And if you are keeping an object between C and F, then image will be beyond C. Two alternative. If you, what focus? If you will keep means if images are coming infinity, from infinity, then image will, objects, if suppose is placed at infinity, so image will form at focus. If object is at focus, then image will form at infinity. Okay? Both are, you can say reverse. Vice versa. From the mirror, I should screen paste from the mirror. It is not there in book. Sir. So that sharp focused image Yes, so you have not attended that offline lecture and online lecture also you have not attended, so you read by yourself all these things. Okay, so let me see, just call it for you. Accept, understand the question? Yes. There are two types of mirror, concave mirror, convex mirror, okay? In concave mirror, yes, see we have now terms also that center of curvature. Mirror is supposed to be a circle, there is a center of that circle, that is known as center of curvature. And radius of curvature what? From the center point, the distance from the center point to the concave mirror. This is your concave mirror. Fine. So it's supposed to be a circle and this is your center. This is center of curvature and radius of curvature will be what? The distance between here to the pole, we can say. that will be your radius of curvature. Then we have a pole, the center of the aperture. Aperture is what? The reflecting surface. Okay, this will not be considered as aperture because here light will reflect only in this part. So whatever the reflecting part is there, that is considered to be as aperture. Next is principal axis. So the line which is passing through the center of curvature and focus and pole, that straight line is known as principal axis. So these are very small things that you already know. Now in the 8th class you already studied image formation, that how to make image formation. Have you practiced on the ray diagram in 8th class? Have you practiced?
All these were.
Yes, all these were there. But here there is one new thing is there, that is like this is your concave mirror. This is the principal axis. So you know that if light ray is coming from parallel, means light ray is coming parallelly and hit the aperture, then it will reflect through focus. So the question is why it's supposed to be pass through focus, not here and there. Because we have one rule, that is the normal line. Normal line, okay, the normal line will always pass through center of curvature. That's why, because if normal line will pass through the center of curvature, it will make angle I, and you know that according to the laws of reflection, angle I should be equal to angle R. So if this is this much angle, it is there, so obviously angle R will be also equal to this much. Okay, the measurement will be same, and because measurements is same, that's why this reflected ray always passing through focus. Whenever parallel ray will come, normal line always pass through the center of curvature. Your normal line is actually deciding or predicting what will be the at what angle reflected ray will fall. Okay, here will go. Yes. So that's why in every, means you can say that in every ray diagram the rules are there that if it is light is coming from parallel, it will pass through the focus. Why it is so? It is not a rule. They have measured that how it will happen. Okay, now why it should not pass here and there? Because of this normal line. That normal line will always pass through center of curvature. So this is your first rule, and second rule was okay. Line, just 1 minute, Aksha, let me recall, and you please also listen. Yes, when light will pass through the focus. When light ray will pass through the focus. When light ray will pass through the focus, so obviously light ray will go through this. Now center of normal line will be what? Always passing through the center of curvature. Normal line will always pass through the center of curvature. I told you that reflected normal line will decide at what will be at what angle the ray will be reflected. So this is your normal. Now you will see that angle I is this much, so angle R also supposed to be this much, and the reason is that this is reflected parallelly. The reason is this, it reflected parallelly. Now third law is center of curvature. Third law is what? It passed through the center of curvature. Light ray passed through the center of curvature. It will reflect it back to the center of curvature. Why? Because if light ray will incident here, so normal line is supposed to pass through the curvature. So normal line will pass through the curvature, and the angle between angle I and normal line, the angle I is equal to 0. Because of that, angle R will also be equal to 0. That's why it passed through back. It passed back to the center of curvature. Fine. Now understood why these laws actually how they made these rules. It's not like that just we told you that V is equals to U, so V is equals to U. No, because we have one rule, and that rule is actually can say predicting or deciding at what angle reflected ray should be reflect or should go on. Done 3 rules. Now one more rule is left. That is Gibran? Pole. Yes. If light ray will incident on pole, normal line pass through the center of curvature, already passing through the center of curvature. It means that following laws of reflection, it will reflect it like this. All rules are clear. And similarly, that's now you can make image and image. Can you make any image on rough notebook? Keep object at center of curvature. Concave mirror always form real and inverted image except one case.
When it is after focus.
When it is placed between pole and focus. After focus. After focus supposed to be here, no? Before focus you should say. No? So it depends on you which reference you are choosing. Okay, it depends on you. I am choosing reference here. Yes, yes. It depends on it's the reference point. So quickly make and then yes, dear, show me your numerical. Let me see what you have done in your notebook. Show me your notebook. You are on the right path. LCM taken incorrect. Aksar, you have taken LCM incorrect. Take LCM properly. LCM will come 54. Yes, Gibran done? Show me. Always you will follow two rules, that light coming from parallel, it will pass through the focus, and when it will go through the incident to the center of curvature, it will reflect it back to the center of curvature. Most of the time you will use these two rules. Third one also you are taking in the center of curvature, then yes. What you have done? When line rule first, that is parallel line will go to the focus, and then when line will go to the focus, it will parallel. Okay, at the same side. Very good. So Gibran, actually now every concave mirror have different measurement. Okay, it depends on us where we will keep image. So every time we cannot do practically, means how we will do practically. It's very difficult every time we will do, because in instrument always error is seems, always error is there. So that's why they have a formula for finding out the you can say initial distance, final distance, height of the object, height of the image. That is known as mirror formula. And what is your mirror formula? That is 1 upon V, 1 upon F is equals to 1 upon V plus 1 upon U. This is your mirror formula. If any unknown thing is given, you can easily find out your one unknown thing. Okay. For that, if this is the equation, so in this equation, if there will be two known things, then you can easily find out one unknown thing. Okay, it depends on the question what they are asking. Sometimes they will give you the distance of the image from the mirror or distance of the object. Don't confuse with this initial and final velocity. U means that the distance of the object from mirror. Distance of the object. Okay.
Mirror or pole?
From the pole, mirror is this one.